All right, here we go. We have Unit 6 test review. We're going to be looking at seasons, we're going to be looking at moon phases, and we're going to be looking at tides. So the first thing I want to go over is seasons. 8.6a. I've not pulled this out for y'all before, but let me do it now. As you can see, and this is a great time for you to, and since no, it's not all on the screen. There we go. You can go ahead and pause this and look at it and read it and check it out. There's a lot of yummy goodness on here. So we have model and illustrate the tilted Earth, that it rotates on its axis, causes day and night, and revolves around the sun, causing change of seasons. So we have a couple vocabulary words here. We have rotation, which is to spin. We have tilt, like to 23.5 degrees, like our Earth is. And we have revolution, which means to go around. So understanding those vocabulary words, very important in this in this teak. So you can see, here's what I'm doing. If I'm you, I'm going to go ahead and draw these seasons out. I'm going to put the sun, and then I'm going to show the tilted Earth. Like here, you can see that the southern hemisphere is tilted towards that summer, so that makes this winter. You got to know the order of the seasons: summer, fall, winter, spring, and then you just go ahead and you notate it all accordingly. So we have the southern hemisphere, summer, fall, winter, spring, and then you flip it: winter, spring, summer, and fall. Just like that. It is sometimes just that easy. So that is your seasons review. Remember that it's 6 months to go from one side to the other side of the sun in the revolution process. And so it's 3 months for each season. Okay? So that's 8.7a. Here we have moon phases. And I'm going to do the same thing. I'm going to go ahead and let you guys check this out. Ooh, there we go. That's a good one. 8.7b. Demonstrate and predict the sequence of events in a lunar cycle. As you can see, that's the straight line starting from new moon, waxing phases to full, waning phases back to new again, hashtag 28 days later. Because really, at the end of the day, I know it's, 29.5, but if you think of it as a month and you count it as 7 days in between the main phases, which are new moon, first quarter, full moon, third quarter, it makes the counting very simple. So that's why I have the saying, skip a phase for 7 days, because you can essentially go from new moon, skip a phase to first quarter, skip a phase to full, skip a phase to third, just like that. And so this is another way to write it, as you can see here. You can annotate your waxing and your waning. And I put WG for waxing gibbous. And then you can see WC can stand for waxing crescent. And on this side, we have waning. On this side, we have waning gibbous and waning crescent. And then the arrows show the way that the moon rotates or revolves around the Earth. And the last thing we have is, and making sure that you always know the location of your sun. And your sun is always on the side of the new moon. So you're going to have a test question that may show you the cycle and say which direction is the sun coming from. Locate the new moon and you know the direction of the sun. And then we have tides, 8.7c. So here we have relate the positions of the moon and sun to the effect of the ocean tides. We have spring tides, straight line, strong tides, as you can see on, this side over here. And then you have neap tides, which are 90-degree angle, and they are weak tides, so they are not strong. So your high tide and low tide, not to be confused with neap and strong tides, they happen every 6 hours. Every 6 hours it's switching. And then you have your strong tides, which are your spring tides. They happen twice a month when you have full moon, new moon. And your neap tides, they happen during the quarters. So that's your tide review. There's a couple other things you need to be mindful of for this test. And we have, remember what a low pressure system brings. L brings, dreary or some rain clouds and that type of thing. It's not very good weather, versus an H, which would be happy weather with no clouds in the sky. We have, please excuse coughs, burps, sneezes, or chunks. What does that mean? It's evidence of chemical change. So make sure that you understand all the evidence of chemical change. When you're looking, topo maps, there's a topo map question in here. Refresh your mind on topo maps. Being able to understand the difference between two different elevations. Acceleration, speeding up, slowing down, or changing direction. We have solstices and equinoxes. Remember that the summer and the winter solstice both symbolize, the summer one will be the longest day of the year, the summer solstice, on or about June 21st. And then we have December, which is the winter solstice, which is on or about December 21st. And that is the shortest day of the year. So the least amount of daylight hours will be during that day. The least amount in the northern hemisphere is, for the entire year, is right around that day of December 21st, which is the winter solstice. And so the longest day of the year is in June, around the 21st, the summer solstice. And then we have the equinox, meaning equal amounts of daylight for the northern hemisphere and southern hemisphere. And that is March 21st, which would be the vernal equinox. And then we have September 21st, which would be the autumnal equinox. What else? We have, so coastal cities, they're on the coast, the humidity is higher, and if there's water in the air, it holds temperature longer. So you don't have greater changes of weather inland and less on the coast. So Florida, for example, there's not great change in their weather because there's a lot of water in the air. So just remember that coastal cities have a smaller temperature range. That's probably the best way to put it. And really, that's about it. There's one other thing that you need to know is that the 1-to-1 ratio of the moon with its rotation and revolution. So let's think about the Earth. The Earth is spinning, right? And then it's also revolving around the sun. So we have 24 hours for one full rotation. And for the Earth to revolve around the sun, it's 365 days. So that's an interesting, that causes a very interesting scenario with the Earth. So the Earth is spinning while it is going around the sun, right? So that's what's happening here. The moon is different. The moon has one rotation every 28 days, and every 28 days is one revolution. So really what's happening is we only see one side of the moon all the time. There's another side that we never see because the moon is always, that one side is always facing because its rotation and revolution is 1-to-1. So that makes for a very different experience, a very different phenomenon than Earth, which is 24 hours, so one day to 365, which is, very, very different than the moon. So that's it. That's your Unit 6 test review, and good luck on the test. All right, see you in class.